Let's now take a look at some special situations when we're factorising these quadratics, starting with the perfect square. Now, you might remember from expansion that the rule for expanding perfect squares, if we had the binomial ax plus b all squared, well, that was the equivalent of this ax plus b times itself, which you can multiply it out using FOIL, but when we do, that was the equivalent of this ax all squared plus 2abx plus b squared. Now we can rewrite this here to say that this is the equivalent of a squared x squared plus 2abx plus b squared. Now, of course, what we're looking to do when we're factorising is to take something that's more in this general form like this, here, and to move it back to its factorised form that we had just here. Now, with perfect squares, the trickiest part about them often is to identify whether or not we actually do have a perfect square. And that's the reason why I've just done what I've done. And I'm going to show you with an example problem. Let's say I had 4x squared and I was adding 20x and then adding 25 at the end here. If I can prove that using an a and a b value that each one of these is true for my statement here, it means that I have a perfect square. So how do I go about doing that? Well, I've got my x squared value that's matched here, but I've got a number in front that isn't currently squared. So I look at the square root of this number. Now, the square root of this 4 here is 2, but of course it could be plus or minus 2. So we could rewrite this as either positive or negative 2 squared, and that'll be multiplying by x squared. And then over here, this needs to be also square rooted to get what my b value would be. So the square root of 25 is 5, but obviously that could also be a plus or minus 5 because negative 5 times negative 5 would be positive 25. And what I really now have here is what my a and b values are in this quadratic. And what I'm now looking to do is, if I was to do 2 times my a value and multiply by my b value, it should equal positive 20. And if that is true, it does mean that I've got a perfect square here. So let's have a look. My a value can be plus or minus 2. So let's just say for now that my a is equal to positive 2. And to get a positive number here, I also want to make my b value positive. So b is going to be equal to positive 5. And if I now do 2 times a times b, that'll be 2 multiplied by my a of 2 multiplied by my b of 5. And 2 times 2 is 4, 4 times 5 is 20. So this equals 20, which, because it does match what I have here, it means that I've now got a perfect square. And because of that, I can actually factorise it back over here. So what I can say is, I can say that this is equal to so open up a bracket here, but it's my a value, which I identified to be positive 2, then my x, add my b value, which was positive 5. And that will be all squared. Now what's interesting here is you actually do have two sort of different solutions here that are the same. So let's say if I made this a to be negative 2 and my b to be negative 5, well, 2 multiplied by my a of negative 2 multiplied by my b of negative 5 is equal to 2 times negative 2 is negative 4 times negative 5 is positive 20. So my a could also be negative 2 and negative 5, which you can replace in here, but when you expand it, it'll equal the same thing. But let's explore why it's the same. So if I did this, I would be saying that this is equal to, my a value was negative 2 this time, so negative 2x. Then my b value was -5 this time, so we subtract 5, all squared. Well, what I can do here is I can take a common factor of -1 out of these brackets. So this would be -1, and then when I factorise by -1, it'll leave me with positive 2x and then plus 5. But of course, this whole thing is squared. So I square the whole thing. Now, when I square this, that means I need to square the first bracket and square the second bracket. So this is equal to -1 squared and 2x plus 5 squared. Now, what do we know about -1 squared? Well, -1 times -1 is +1. And +1 times this will just be this. So this is the equivalent of 2x plus 5 squared, which is what I had over here. So in essence here, while it does appear that we have two solutions, they are equivalent to each other. So there's two different ways that we could represent this. Now, as with all factorising, we can always check to make sure that we've got this correct. So let's do a check step now. So in my check step, I'm just going to rewrite this. Well, I can rewrite this to be my 2x plus 5 multiplied by itself. And then I'm using my FOIL. So, as I use my FOIL, my 2x times my 2x will be 4x squared. My 2x multiplied by my 5 will be 10x. Then my 5 times my 2x will be another 10x. And then my 5 times my 5 will be 25. So now I collect my like terms. So I've got my 4x squared. I've got 10x plus 10x, which is 20x. And then I've got 25 at the end. Now, when I expand this, I match what I had to begin with. So it means that I've factorised this correctly. So to summarise, the most challenging part of factorising by the perfect square is to identify that you've got the perfect square to begin with. And to do that, you consider the coefficient of the x squared term and square root that, and square root the constant term to identify what your a and your b could be. And then you look at, could you multiply the a and the b together and multiply it by 2 and it equal the coefficient to the x? And if you can, it means that you have a perfect square. And with your a and b value, you put it back into this format here.